Hello, welcome back to Math 245. We are almost done learning new material for this course. You guys are so close to being done. Good job. I know it hasn't been an easy term, so give yourselves a pat on the back for sure. The rest of the term we will be talking about statistics, and today we have three lessons, 55, 56, and 57. This lesson is about something called the normal distribution. You may have seen this if you've taken any sort of stats class before. This is related to statistics. So let's go through some definitions here. The normal distribution, also known as the Gaussian distribution, is a continuous distribution that is widely used in statistics and most other disciplines. A special normal distribution called the standard normal distribution is the distribution of something called z-scores, which we will talk about later, where the mean is equal to 0 and the standard deviation is equal to 1. Remember, we talked about standard deviation last time. So what's so special about normal distributions? Well, they are symmetric around their mean, so that means that the right side of the distribution will be the same as the left side, and vice versa. The mean, median, and mode of a normal distribution are equal, so we don't have to differentiate between the mean and the median because they will always be the same. If we were to calculate the area underneath the curve of a normal distribution, it would always be 1. They are denser in the center and less dense in what we call the tails or the ends as we deviate away from the center. They are defined by two parameters, the mean, which we call mu, and the standard deviation, which we call sigma. Approximately 68% of the area of a normal distribution is within one standard deviation of the mean, and approximately 95% of the area of a normal distribution is within two standard deviations of the mean. One common application of the a normal distribution is grades in a class. So it's possible that you've heard your professors or instructors talk about the distribution of the grades, right? So if the average grade in a class, for example, is a C, right? That would be your mean or your mode, or in this case mean, median, or mode. And then there are fewer people who get, B's and D's. And then there are even fewer people who get A's and F's. So the most people get C's, fewer people get D's and B's, and even fewer people get F's and A's. So this is kind of a common example of how we can use normal distributions. So let's use this following chart in order to answer some questions. It says the middle distribution labeled B is the standard normal distribution. What is the mean and the standard deviation of this distribution? So I see up here the standard normal distribution has a mean of 0 and the standard deviation equal to 1. So that means if this is my x-axis down here, right, then my y-axis would be here because it is this is 0, right, when we're centered around the mean or the median. So since the center right here is 0, that means that my y-axis would be there. So the mean, mu, is equal to 0, and the standard deviation, sigma, is equal to 1, since this is the standard normal distribution. Which curve has the smallest standard deviation? So remember, standard deviation represents the spread of the data from the mean or the median. So I want the spread to be the smallest. So which curve has the smallest spread or the smallest amount of inconsistencies? Well, we see that A has a pretty small spread, right? All of the data seems to be really closely clumped around the mean or the median in A. In B, our data is a little bit more spread out, so our standard deviation is a little bit higher, and in C, it's even more spread out. So A has the smallest standard deviation. Because, according to the graph, the spread is the smallest. So when we're looking at these kinds of graphs, the x values here represent the values that the data is taking on, and the y-axis represents the frequency, right? So if we were to create a frequency table, this would be the values here on the x-axis, and the y-axis would be frequency. So in part C, which curve has the largest mean? Remember, this mean is referring to the values, not the frequency. So I'm looking for the curve that has the largest mean value. The mean is the center of the data. So here's A's mean, here's B's, here is C's. And I want the highest x value for my mean. And I see that C has the largest x value for the mean, right? Here's A's, here's B's, here's C's. So C's curve has the largest mean. Its mean is to the right of the other two. All right, let's go on to another question. If the mean of a normal distribution is 4, what is the median? Well, something really important about normal distributions is that the mean and the median are always the same. So if the mean is 4, then the median also has to be 4. Um, by the way, in case you're wondering what a distribution actually means, it just means how the data is distributed, right? It just means how, if we were to plot all of our data points, the values and frequencies, what would the data's shape look like? That's what a distribution is. All right, one last example for normal distributions. Use the following normal distributions labeled A and B to select all of the following statements that are true. So let's look at the mean here. I see that the center of the curve A is here, and the center of the curve B is here. So that tells me that the means are the same. So the means are equal. And what about the standard deviation? I see that A's spread is relatively small, right? I see that most of the data around the mean of A seems to be clumped around the mean, but B's spread is larger because it's a little bit flatter. So the flatter a distribution is, the more spread out the data is. So that means that B has the larger standard deviation. All right, so this was a brief introduction to normal distributions. Go on over to lesson 56. I'll see you there.